For testing physical concepts for the full-scale aircraft, we keep things super high level at first, whether that's a conversation, an idea, or a concept. We really want to talk and get the right idea figured out before we throw money at it and a lot of time, because we have a small team and we want to move quick. Once we're happy with a concept, we'll make a quick, scrappy 3D model, which we call a cartoon. This helps us make sure things fit together a little bit quickly, but we'll inevitably have to use VR goggles to hop in there and visualize at a higher level, or make a quick, scrappy prototype and then test that, both of which will allow us to make sure that what we're thinking works, make sure it's the right scale, make sure it'll fit in with the rest of the systems on the full-size aircraft or on the half-scale prototype, all before throwing what comes up to thousands of dollars often into a full rig that's fully engineered and ready to go for testing.
Yeah, so really testing is all about validating our expected results. You go into physical testing to see how closely those correlate to our design and simulated results. And if there's a big deviation between your results to the design, then you just, close the loop, go back to design point, resimulate, make your next test model anyway, whether it's prototype, whether it's the fan, stator, louvers. But yeah, that initial cycle on small and the full scale is always just a closed loop between design, simulation, and physical testing.
For some small stuff, we kind of know that it'll scale fairly well from small scale to large scale. And we have obviously a lot of math behind a lot of this, so we can kind of make some assumptions and make sure they're true. But for some other things, we know that the large scale will work very differently than the small scale. And so what we end up doing is actually building a section of, or test rig, or an actuator that's a small encapsulated section of a piece of technology that's actually at the large scale, like of a representative size, basically. So one such example is the wing cover actuators. We've tried them at a small scale for a 50% scale prototype, but on the large scale, we know there's a few things we want to change, a few things that'll be different. Loading will be different, material strength will be different. So we've actually built an actuator for a single X7, like full scale wing cover actuator. We have that test stand in our shop. It's the right size, it's got the right power, and we can put representative loads on it to mimic air loading and turbulence and those kind of things, and make sure that it can actually actuate the wing cover open and closed at a full scale with the right weights, make sure the motor doesn't bog down, make sure we have the margins that we want to make sure that we can handle sort of contingency scenarios and those kind of things. So for some stuff, we can scale it up and be pretty happy with that, but for a lot of things, we have to build a full-scale test rig to make sure that the assumptions we made at the small scale still hold true at the large scale.